Hello everyone, my name is Emmanuel and today we are going to be creating an AI agent that can write clean and clear LangGraph code for you if you want to create an AI agent with LangGraph. This AI agent would has the ability to scrape information from various links of LangGraph documentation and write clean codes for you if you are looking to build AI agents with LangGraph. So let's dive into the code real quick. So right now we are in Windsurf IDE. Windsurf IDE is one of the best, or the best, if I'm not mistaken, agentic IDEs that are out there. We also have Cursor and Client, but for me, I prefer Windsurf. So let's dive in. If you want to create a project like this with CrewAI, it's very simple. You just have to use the CrewAI CLI, writing CrewAI create flow and coder underscore AI. It will create this project structure for you apart from the LangGraph knowledge and the knowledge file and the generated code. So it will create the source um, document for your source code for you and everything you see below. So let's do this. So when you've done that, then you also have to create a virtual environment. Virtual environment is very good so that you can install your dependencies and every framework you want to install. So if you want to create your virtual environment, all you have to do is use python -m venv.virtual environment, and it will create it for you. Then if you want to change to your virtual environment, then you have to activate your virtual environment with this, which it will show you um, before this line. It show you in brackets VENV, or it will just show you the name of your folder, which is coder underscore AI. So once you've done that, then we can start explaining our code. Let me start showing you the agent that we have for this project and everything. The agent we have is the documentation processor. So this is the role, the LangGraph documentation processor, and the goal is to extract comprehensive information from LangGraph documentation, including text and visual environment, and generate a structured markdown for storage in a knowledge folder. And this is the backstory. And also we also gave it a multimodal capacity because there are some diagrams in LangGraph documentation that our AI agent needs to see and understand. So let me show you the LangGraph documentation to see what I'm talking about. LangGraph documentation, this is a documentation on how to define your graph structure or how to update graph states from Node. So right now we can see an image. This is a graph flow. Um, so we have to give our agents multimodal capabilities to understand images like this. Is the LangGraph concept planner. So this an agent that will analyze the user requirements for the LangGraph AI agents and determine the most appropriate LangGraph concepts. So right now, we have the goals, we have the backstory, and we didn't allow dedication and we set variables as true. Then this is the AI agent or the agent that would create the LangGraph codes for you, which is called LangGraph Coder. We gave the role of the LangGraph implementation engineer, and the goal is to design and implement efficient LangGraph code based on the process documentation, and then execute and verify the code functionality. So we have the backstory, and we have max retry limits set to 4. I set it because if you don't set this, your AI agent might run up to 10 times and it can burn all your API credits. So right now we are in tasks.yaml file. So our first task is the process documentation. So we've given it all the AI and LangGraph documentation link that we can find on the LangGraph website for it to scrape. So there are more than 60 links right here from LangGraph documentation. There might be a better way to do this. You can do this through NCP or other ways, but just for this tutorial, we are using the hardest way. So let's go. So we also have some information right here. of the task, which is extract comprehensive information about LangGraph concepts, pattern, and best practices relevant to building a agent type. We'll set this agent type in the main.py file. Focus on understanding core concepts, implementation details, and practical usage. We also have some other information about these tasks which the AI agents will read. So with the expected outputs, a well set of organized markdown file containing comprehensive information from the LangGraph documentation, including text and visual concepts with emphasis on components relevant to building the type of AI agents that you want. So this task is assigned to the documentation processor. We have our next task, which is the plan LangGraph concepts. So this task will be used in planning or in planning the type of AI agent you want, which API you want. We have in the description, we have consider factors such as the complexity and nature of the agent's decision process, state management requirements, human in the loop capabilities, multi-agent coordination requirements, so integration pattern, error handling, and recursion needs. So we have the expected outputs, and this will be assigned, like we all know, the LangGraph concept planner. The context of this second task will be the first task, which is the process documentation. So the output from process documentation will be passed or will be used by these tasks. And this, so we also have human input, which is also human in the loop. You can when you run this, you will see in the terminal, information about how the AI agents want to write the LangGraph code. So you can change it. You can tell the AI agents, oh, do this, don't do this, do that, don't do that, and so on and so forth. So our last task is the generate code. We have the description right here. We have the expected output, which is fully functional, well-documented LangGraph code that implements an AI agent type that would, with all code saved to the output directory and organized in a clean modular structure. So we can see I've run this code already, and the output is in this generate code folder. So I'll show it to you, at the end. So that's all for our tasks.yaml file, and right now we'll be going to the crew. We are in the crew.py file, and let's start from the beginning. So right here we are importing all our dependencies and libraries and tools from CrewAI and everywhere. We're also importing operation system, importing pathlib, and we're also importing load.env to read our API keys. So right here you can see I'm using OpenRouter. OpenRouter is very good because it has all the AI models in it, so no need going from Anthropic dashboard to OpenAI dashboard to Gemini Studio to get all your API key. You can just set one API key for all the models you need. So we have 4 LLM. I did this because I was testing with different LLM to see which one would work very well for each task. So right now I'm using Gemini 2.5 Pro. I'm also using DeepSeek R1, Sonnet 3.7, Claude 3.7 Sonnet Thinking, the thinking model. I'm also using DeepSeek R1 from Samba Nova. Samba Nova is very good because it reduces your latency and makes the running of your AI agents really, really fast. So right now we have our crew brace, and we are setting our class, or we are setting our crew, which is named LangGraph Coda Crew. These are some doc string, and we are calling the agent .yaml file, and also the tags.yaml file right here, and also the output directory. We are setting where the codes will be stored, which is generate code folder. So we are initializing all our tools. We are making directories, the code output directory, and we're checking if it exists. If it does not exist, it will create one itself. We're also checking the directory for the memory. We are using long-term memory. If you go over here, we are using long-term memory from CrewAI memory. So right now we are also using a concept from CrewAI called before kickoff. This will check if our code directory is set. If it's not set, it creates one for us. So we're defining all our agents from the agent.yaml file. So the document processor agents, we're setting multimodal true. I know we did this, we set this in the agent.yaml file, but we're still setting it here again. I think I have to do this one. We're setting the request permits to 16 so that we won't burn out all our API keys, API credits. We are setting the max iter to 12. And we're using LLM2. LLM2 should be Claude 3.7 Sonnet thinking. I think I have to change this because we don't really need a very big model or a very powerful model for scraping. Then the second AI agent is LangGraph Concept Planner. We're setting the max request per minute to 10 and the max iteration to 6. We're also giving it tools. Yes, also in this first agent we gave it the document crawler tool. Don't worry, I'll show you the document crawler tool and everything that's in the code. And the second agent we are giving the separate dev tool. We are giving search URL which is Google. So to search from Google and it will return the top 8 results. We're also using we also have our third and last agent, which is the LangGraph coder, and we are giving it the file writer tool, which is to write our codes into Python files, which we will see in this generate code folder. So we're defining our tags right here, and we are creating the LangGraph coder crew. We're using long-term memory, and we're using the LangGraph. We're using long-term memory from CrewAI. We're also setting planning, so it has to plan for before it writes or carry out any tasks. We're setting variables to true, and we're calling our agents and tasks that we define in the YAML files or the two YAML files in the config folder. Yeah, so let me show you the documents crawler tool. So right now we can see our scraper tool, which we used in the crew.py file, which is the documents or the documentation crawler tool. Right here we're importing all our libraries and everything. We are importing the base tool from CrewAI, and we'll also be using base model and field from Pydantic. So right here we are defining our base model. This will take care of, or this is the input that will go into our base model. So the first one we have the list of documents or list of URLs to crawl. We have the list of URLs to crawl. We have the output directory. We have the output directory. We have the output directory where we'll save our codes. The other one from line 17 to line 20, we have the max depth, and this will control how many links away from the original URL the crawler would follow. We've set it to 1. We also have concurrency. This is the number of concurrent requests to make during crawling. Or this also sets how many URLs to crawl, how many URLs the crawler will fetch in parallel. We also have the cache mode. And this controls how Crawl4AI. Yeah, sorry, I forgot to mention, we were using Crawl4AI in this to create this custom tool using Crawl4AI. It's free of charge. You can also use SEPA, Dev, or Tavily, or Exa, but for this I used Crawl4AI because, like we saw in our tasks.yaml file, we have more than 60 document links to crawl. So using a closed source platform like Exa or Tabity will burn up all your API credits. So we're using an open source which is CrewAI. And the other reason why I use CrewAI, because they have a simple way on how you can scrape or how you can scrape um, different or multiple links in batches. So we'll see that below. So right here we're defining, or this we have our last section in the base model, which is the fit for LLM, and this tells the tool to optimize markdown outputs for the use with with the large language model. So we have our base tool, and this is the tool that the AI agents or the agent that this tool was assigned to we use. So we have the description. You can see the description, crawl and process documentation URLs, extracting content including text, code examples and diagrams, so on and so forth. We also we also have the we also have the we also have the run we also have the run call function, and this is the function that will be called by CrewAI when the agent uses this tool. This also defines the function signature, matching the schema fields that we saw in the base model above. Then we also have some arguments for some args, which is the summary of the crawling and processing results. So these are the summary of the crawling and processing results, and they also match the schemas that we set here and the schemas that we set in our base model. Yeah, so this also returns, so it's showing you what it return, a summary of the crawling and processing results. So this piece of code right here, from line 68 to line 74, we're importing async web crawler. So this will crawl different links in batches. It will crawl different links in batches and also at the same time. So instead of crawling one link at a time, it will crawl different links at once. We're also using the async IO. We are importing our operating system. We are using JSON, and we are giving this to date time. So we're ensuring that the output directory exists. It does not exist. The output directory, which is the generate code directory, it does not exist. It will make one for us. So we are crawling. We are we are setting how our links should be crawled by instantiating this instance, which is the CrewAI async web crawler right here, and we are um, putting our settings. We're using cache mode. We're saying if there's no cache mode, then we would put it in our memory. We are setting the max depth, and we're also setting concurrency, which means I think this would um, perform our attacks in batches or so, if I'm not mistaken. So this this piece of code run in this piece of code we are using a run many from CrewAI, which means it will run it in batches. It will run, and it also run our link synchronously. So for this piece of code, we are setting how the results will be saved, and this prepares to track where the files will be processed and summary starts to be saved. So if we have successful, it will tell us how many successful runs we had. If it fails, it will tell us how many failed runs we have, and the process files. So this right here, this piece of code right here would instantiate the summary. No, sorry, this piece of code right here will look through each result. Each result will look through the core results, one per URL, with the I as the index and results as the crew results objects. I'm talking about this line 99 and line 100. So line 99 also checks if the crawl if it also checks if the crawl for all the URLs were successful. If it's successful, then to create a file name like doc1 md and so on and so forth for each of our crawled links. Then it also constructs line 102. We also construct the full path of the markdown file in the output directory. Then from line 104, 105 and 106 would use the crawl for AI get markdown method to convert the crawled contents into a markdown, optionally optimizing for the LLM if fit for LLM is true. Then also um, in line 108 and line 109, it prepends the source URL as the heading on the top of the markdown file for traceability. Then from line 1110 to line 112 right here, it opens the markdown file that we created for writing and save the content there. And from line 114 to line 122, it sets the path for the metadata dictionary file in the documents. Also creates the metadata dictionary with the URL, crawl title, crawl time, and the HTTPS status code. Then in line 123, it saves the metadata dictionary as JSON file, and also for this part of the code right here, it adds the markdown file path to the list of processed files. It increments the count of successful crawls and adds record to the summary process file list, mapping the URL to the file paths. So that's just it. This right here, this generate and save the summary that the summary of the script content that we got from LangGraph documentation, and this returns a readable summary, and this is our error handling code, and so on and so forth. So we have to go right now to the main.py file right now to see how we created our flow. So right here we are in the main.py file. So right here we are importing all our libraries from .env from Pydantic. We're also importing our flow listing and stats from CrewAI. We're also importing our code that we created in the crew.py file, which is called LangGraph coda crew. So right here we are creating, or we are defining our Pydantic base model to hold the application states throughout the flow. If you don't understand what this means, I advise you to go and read the CrewAI documentation very well, and you understand how to create flows using create states in CrewAI using structured method, which we are doing right here. So this create the Pydantic base model to hold the application state throughout the flow. All information gathered or generated during this flow will be stored right here. I'm talking about all this will be stored right here, both the execution results, the execution status, the generated code, the code files, the code output, the knowledge base, so on and so forth will be stored in our base model state, which is called LangGraph coder state. Then we start defining our we start defining our main flow right here, and line 47 defines the main flow class inheriting from the flow and specifying that it uses the LangGraph coder state to manage its states, and an instance of LangGraph coder states will be automatically created and available as states within the flows method. So we are giving our flow the states, so whatever stored in the states our flow will know. So we're using the stats decorator that we got from CrewAI to start from the get agents. So to get the agents, to get the type of AI agents you want to build. So we run this in your terminal. It will tell you to put a short summary of the AI agent you want to build. When you've done that, it will generate the LangGraph code, and we also have this. We also have another flow called generate LangGraph agents, which is also listening, or which is also listening from the output gotten from the get agent type, and this generates LangGraph agents generates the LangGraph agent based on the specific type that you set in the get agent type function. So all this, it's creating knowledge base, it's creating knowledge file, it's creating the output directory, it's creating the code in the output directory. This right here, it stores an explicitly provided generated code path. So it's storing the code generated, the execution results, the execution status, any errors right here. It will tell you if there's any errors, and to give you 100% if it has finished loading. So right here, display results will listing from the output that the generate LangGraph agent gives, and it will display the results for you. And all this code right here in this function handles each and every one of it, and when you finish, it will tell you flow completed successfully, and we will kick off our LangGraph, our flow. And also this piece of code will also enable you to plot your flow. So that's all for this AI agents. I hope you understood what I said. If you have any question, please leave a comment for me and I'll answer you. We also have in the py project.toml file, we are importing dependencies like CrewAI, Crow for all, Python.dev and Docklin. You can use UV to install all these dependencies. And for the output, so if you go to our crew.py, you see that our LangGraph coder is using LLM, and the LLM is the Gemini 2.5 Pro, and this is the output that it gave. I think I put that first of all, it created a source folder for us where you can see the state.py codes. You can see the notes. If you don't understand anything about LangGraph, you need to educate yourself. LangGraph is very good. The only problem I have with LangGraph is that it's 100% Python code, while CrewAI is mixed with both Python codes and some simple English when you want to create it. So we have the node.py file, we have the model.py file, and we have the graph.py file. That's what is in our source code. And in the main.py, we are linking everything together. We are creating, I think this should be, we are creating the states right here. Okay, this is the state right here, and we are calling it, if I'm not mistaken, post creator states. Okay, so yeah, so it's calling this post creator states in the main.py file, and these are the schemas that it will take, and this is the final states, and it's just doing what's I think I said that I need to build um an AI agent that can write LinkedIn posts for me. I'm not really sure. Yes, that's what I said that it should build. So if you run this CrewAI code in your terminal, you will see where it's telling you to put a short description of the AI agent you want to build, and you know you also have human in the loop in one of the tasks. So you can tell the AI agents what you want in the code and what you don't want in the code, so on and so forth. So not to make this video to be very long, I didn't really run the codes, the LangGraph code that it gave to me. I'll run the letter. Also give us a requirement.txt file. The dependencies you have to install, and also the only error that I see that it's made is that it didn't write anything in the readme file. Okay, excuse me, it didn't write anything in readme file, and I think that's because I set give me a minute please, in the LangGraph coder, the agent that writes the code, I set the max iter to 8. So if it runs 8 times and it will just stop, okay, it would give you the output whether it's completed it or not. So you can increase this to maybe like 20 or 30 if you have so much API keys on OpenRouter. And also maybe you can also increase the max RRP. And in a tax, is it tax or give me a minute? I think in the tasks.yaml file. Okay. Give me a minute. Okay, so that's just all about it. So you can run this AI code and also generate your LangGraph model, your LangGraph code, and run your LangGraph code if excuse me, if it works. You can also in the crew.py file you can change to other models, maybe like the latest llama 4 or the latest GPT 4.1 or 4.5 if I'm not mistaken. Yeah, so you can see which model does best in writing the LangGraph code and which model does not do best. Yeah, so if you have any question, leave it for me in the comment section and I'll answer whatever question you have. Thank you.